Hello, everyone. Good afternoon, and welcome to the lecture on glaciers and glacial landforms. So it's a basic lecture that will give you information about what are glaciers and what kind of landforms the glaciers make. Um, so what will we learn in this presentation? Here are some things, a list of things. So the first one is, what are glaciers and why is it important to study them? How do the glaciers form? What are the different types of glaciers? How do the glaciers move? What kind of movements do the glaciers show? Do they advance? Do they retreat? And the glacial landforms. So, starting with, what are the glaciers? So, you must have heard in today's world that, oh, glaciers are melting, oh, the climate is changing. But have you ever wondered what the glaciers are actually? So, the basic definition of glaciers is like a glacier is a mass of snow, ice, rocks, sediments, and often liquid water that gets a mass addition yearly, and it shows internal movement or internal motion. Um, Usually, it means that there should be visible evidence of motion and evidence of motion inside the mass of ice, and the ice mass is often more than 20 meters in thickness. So here are some pictures of different types of glaciers that are found on the planet. So glaciers can be of different shapes, sizes, and forms. And yeah, here are a few pictures, few examples. And what is glaciology? So glaciology is the science of ice. And with ice, we mean ice in all kinds of forms and all sorts of frozen waters. It can be sea ice, periglacial ice, snow, frost, avalanches, extraterrestrial ice, glaciers, and ice sheets. So in this lecture, we will mostly focus on glaciers and ice sheets because they're a topic in themselves. And the people who study these water in frozen form, they are known as glaciologists. They also do research on glaciers and all these, the cryosphere regime in the world and in outer space. Here are some pictures of glaciologists working in the field. And they get to go to these beautiful places with pristine environment and carry out researches in different forms and about different problems. Uh, yeah. So that brings us to the question, why do we need to study the glaciers? What is the requirement? Why is everyone talking about glaciers? So there are many different reasons for that. So the first one is self-interest, because glaciers are, we have to admit, very beautiful, and they create some amazing landforms. And people they can go to photograph them, study them, and for leisure and tourism as well. Then we have academic interest. We want to understand about the processes happening on Earth, the landform development, the geology, uh, the previous climate, physics and chemistry related to glacier movement and the surface of the Earth. Of course, glaciers impact the climate directly and vice versa, so it makes it even more important to study glaciers. Then we have different feedback loops, which basically means how glaciers are impacting the climate and vice versa. And then we have sphere interaction like atmosphere, cryosphere, hydrosphere, lithosphere, etc. And then the last one is social interest. So these include glacier acts as natural resources. They give us information about hazards in mountainous regions. They're also responsible for fresh water supply to huge parts of society and for generating hydroelectric powers, like electricity and hydroelectric dams, infrastructure, tourism, and of course, they are highly associated with global warming, sea level changes, and regional climatic conditions. And here are pictures of the Polish polar station in Hornsund in Spitsbergen, where glaciologists and people in other scientific fields go to study glaciers and different spheres that interact with glaciers. And in the second image, you can see where this station of Polish polar station is located, like way far up north. So, how do the glaciers form? So there are certain criteria that needs to be met for the formation of glaciers. And the first one, obviously, is very cold local climatic conditions. So here we have a diagram of our planet with different zones like equator, the equatorial region, the tropical region, the Arctic region. And of course, since our planet is tilted on its axis, the sun rays reach at different angles at different places. So since the sun rays reach obliquely in the polar regions, they do not have that much relatively lower heat impact. So the regions near the poles, they are relatively colder than in the central part or the equatorial regions of the Earth. So the very cold local climate conditions, they get satisfied mostly in the Arctic regions. And it's usually difficult to find uh, e- um, glaciers in equatorial or tropical regions, but then there are also mountains. So mountains bring height and altitude. So with increasing height, the temperature often decreases. So we do find glaciers in the tropical and equatorial regions as well, but on high altitudes and mountains. The second criteria is large amount of snowfall, which also gets satisfied on Arctic regions, polar regions, and in high mountain regions like in Alps, the Himalayas, the Andes, etc. And the third criteria is accumulation. The snow that falls, it should last through the summer, that it does not disappear when the summer season comes. So these conditions also get satisfied. And then usually glaciers are, since I mentioned before that there needs to be some sort of internal movement or motion, usually gravity is helping with that, along with the own weight of glaciers that help them in performing some internal motion. And here is another diagram showing like the formation of glacier. In the topmost region, uh, sorry, just a second. Yeah. In the topmost region here, the snow falls in the cold region, cold zone, where it stays, and it's called the accumulation zone. Here, the snow the ice mass, it gets collected. And as the snow falls, the lower layers of snow, they start getting compacted as more and more snow falls on top of it. So the type of snow crystals, they get changed and they get densely packed along with time. So the lower layers, they get more and more dense, and the air between them decreases. And at one point, the snow packet starts to become more and more thick. And because of the gravity and the mass of the glacier and the slope, it starts moving downwards. And then um, the region below is called the ablation zone, where the glacier starts to lose mass or lose snow through various processes like sublimation or melting and calving and breaking of icebergs falling into the sea. So this is the process of glacier formation mostly, and glacier melting and calving as well is shown in this. So this kind of diagram represents a typical mountain glacier mostly. Uh, sorry. Mm, sorry, technical difficulty. Uh, yeah, yeah. And here's another diagram which represents glaciers in polar regions, in Arctic regions, uh, because sometimes they're also found in places where the altitude is not that high or the height is not that much, but the glaciers still form. And here the accumulation happens on less sloping surfaces, and the movement happens more horizontally, like as the snow accumulates, the glacier starts to spread out from the thickest point of the glacier. And again, the in the outer regions of the glacier, we have ablation, that's ablation zone, where evaporation and sublimation of glacier is happening and the glacier is melting as it moves far and far from the zone of accumulation or the place of highest thickness. So as I described earlier, there are two types of glaciers mostly, mountain glaciers and continental glaciers. So in mountain glaciers are the glaciers formed adjacent to the mountains or on the mountains, basically in the valleys or on top of mountains. Um, the temperature needs to be really low and cold, which we get with increasing height. So higher the mountain is, the more chances of glacier formation are there. Uh, Glaciers often flow from higher to lower elevations. And these are the examples of the mountain glaciers: the Himalayas, the Alps in the Europe, Andes in South America on the Peruvian and Argentine coast, and then Southern Alps in New Zealand. Then we have mountains in Alaska and mountains of Western North America. And for continental glaciers, they are vast ice sheets spread over thousands of kilometer squares of continental crust. They are mostly found in polar regions, and as I mentioned earlier, they flow outwards from their thickest point, unlike the mountain glaciers which slope from higher elevation to lower elevation. And in continental glaciers, we can only describe two places, which are Greenland ice sheet and Antarctica ice sheet. Continental glaciers can also be found on other planets, like for example, Mars. They also have a polar ice cap on one of the poles or of the Mars. So these are the basic differences between the mountain glaciers and the continental glaciers. So first we will see what different types of mountain glaciers are there. So we have cirque glaciers, valley glaciers, mountain ice caps, and Piedmont glaciers. So here's a diagram showing all these different types of glaciers. So cirque glaciers, which are this one, basically forms when there is a hollow space, like a bowl-like space depression on the side of the mountain. And that's where the snow gets accumulated or collected. So this is called the cirque glacier. And when the valleys between two mountains, they get filled by glaciers and ice, they are called valley glaciers. Then we have mountain ice caps, which look like they have submerged all the adjacent mountain peaks. So that looks like a mountain ice cap. And then we have Piedmont Glacier, which basically is when glaciers, when they move out from the valley into the adjoining plains, they spread out like this big giant elephant foot, and these are called Piedmont glaciers. So these are the most important types of mountain glaciers. There can be more different types, but we will not get into that. Um, Then we have continental glaciers. And as I mentioned, there are only two continental glaciers on our planet. And they are Antarctica ice sheet and we have Greenland ice sheet. And they have very large surface areas. So approximately 14 million square kilometer is the area of the Antarctica ice sheet. And for Greenland ice sheet, the approximate area is 1.7 million uh, square kilometer, which is almost 80% of Greenland's surface. So here are images of the Antarctica ice sheet. And then we have the Greenland ice sheet here. So as you can see, the Greenland ice sheet, it is mostly covered. Greenland is, yeah, mostly covered with ice, and here are some non-glaciated regions in the margins. Here's the capital Nuuk. And yeah, so now we will see how and why the glaciers move. I've already mentioned it, but we will look at it again. So on the mountains, the glaciers, they basically form on a sloping region with a gentle slope. So definitely the gravity acts, and the mass itself of the glacier allows it to have some shear movement, and then they start flowing down the valley. Also, the base of the glacier is uh, rocks and sediments, so it starts melting first. So and then because of a formation of slight liquid, the glacier starts to slide over it. Um, Here you can see a nice example of with honey. Basically, it's a way to demonstrate how a glacier flows because of viscosity of honey. So if there is a slope with some grooves and ridges, honey will the movement that you will show of flowing honey, it's kind of similar. It can be related. And similarly for continental glaciers, they move outwards from the thickest point, just like honey, pouring down honey on a flat table. So it's a very easy way to remember how the glaciers move. And here we have a little video of the glacier advance and retreat. Because when glaciers move, they can expand or they can become shorter depending on what is happening. Uh, let's see if I can play this video somehow. Yeah. So in this first scenario, we have the stationary glacier where the accumulation through snowfall in the top of the glacier is equivalent to the amount which is being melted at the bottom of the glacier. So when these two processes are in equilibrium, the glacier stays stationary, even though the ice is flowing downwards, even though the glacier is flowing downwards. So we can have a look at it again, the stationary position. Yeah. And the second one is the glacial retreat. Here, oh, sorry. Yeah. Here, the the amount of ablation um, is happening faster in the zone of ablation. The melting is happening faster than the amount of snow being accumulated at the top of the glacier. So this results in the backward movement of glacier from the toe, which means glacier retreat. That means the glacier is slowly becoming small, and still the snow and ice, the glacier, the flow is still downhills. Yeah, we can see that again in the animation here. And then we have the third scenario, which is glacier advance. Here, the rate of accumulation exceeds the rate of ablation, and the toe advances and the glacier starts to become thick or advance. So these are the three basic types or scenarios of how glacier moves or stays stationary. So when we talk about that the glacier is retreating or melting or becoming smaller, so this is the phenomena that's happening. Like snowfall is one of the most important criteria in glacier advance or retreat, and it highly depends on that. The melting is continuously happening, but snowfall plays a major role. And now we will talk a little bit about glacier landforms. So here is a video, animated video about how the glacial landforms are being shaped. I'm not sure if you can hear the sound, but let's see. Can someone send a thumbs up if the sound is audible? Can you hear the sound of the video? Can someone tell me that? Okay, thanks, Tanmay. So glaciers are basically frozen uh, rivers of ice as per the video. If you can't hear it, I'll just explain what's happening here. And they are like very big and powerful natural way of carving. They are like bulldozers basically, which carve the landscape of our planet. So here's an animation of comparing glaciers to the bulldozer of the nature. And when the glaciers they move down the slope, they basically erode the surface of the bed, and then they pick up the small pieces of rocks and the loose sediments on the surface, which gets flown down together with the glacier. And in this process, they hit and scrape other loose sediments, um, and they erode them as well. Oops, where did my video go? So here you can see erosion is happening. So the water flowing along the base of the glacier, it also falls down into the cracks and crevasses on the surface bed, and then this water freezes in the crevasses and the cracks, and when it freezes, it makes the rocks come out loose, and they also start flowing down with the glacier. So as you can see, it's called freeze and thaw weathering. So the loose rocks that are flowing down along with the glacier on the bed surface, they basically erode the surface of the bed, and it's called abrasion. They act like sandpaper. So eventually, glacier transports all this material, which gets mixed in the glacier flow during its movement, and it can be lots of different types of sediments, rocks, and impurities, sand, basically a mixture of everything, and rocks and sand of all different sizes. And when the glacier reaches the end or the plains where the slope ends, and it starts to melt because of the lower altitude or more um, uh, more higher temperatures, the glacier toe starts to melt, and everything which is inside the glacier, it starts to get deposited. The sediments and the rocks, everything gets deposited, which is called glacial till. So here's the process of deposition. And here we can see some till, which is the part which is left behind after the glacier has melted. And the water that has melted, it forms into streams and rivers, which flows downhill and basically helps in agricultural purposes or other um, societal requirements. So the glacial landscapes can look like this when the glacier has melted and eroded and created, um, eroded, deposited. They create such sort of landscapes like huge valleys and yeah. So that's about it about the video. So now we will look more closely into what different kinds of landforms does the erosion of a glacier form. So here you can see this image. So it's a process of before glaciation, during glaciation, and after glaciation. So before there is lots of snow and ice in a mountainous region or landscape, we usually have V-shaped valleys, which are basically carved by river streams. And then we have tributaries, valleys that are tributary valleys that are joining the main river valley. And when the glaciation happens, when these places are completely filled up by snow and ice, it kind of looks like this, the glacial landscape. Uh, Basically, all the valleys and all the um, place gets covered by ice. And as we learned earlier, we have valley glaciers, then we have ice caps and cirque glaciers, which form in a bowl-like formation. And when the glaciation has ended and the glaciers have completely melted, they leave behind these landforms, which look like this in the third image. We have U-shaped valleys here because before initially they were V-shaped valleys formed by the river. Now the erosion is much bigger, and then they form something like U-shape. And then the cirque glaciers, which used to be here, they leave behind these hollow bowls. They are called cirques. And then we have arites, which are basically ridges, which forms when two or three cirques occur adjacent to each other on sides of the mountains. So we have these mountain ridges, which are called arites. And when we have more than three cirques next to each other, we form something. There is something called horn that is formed, which is basically like uh, two or three or more ridges are meeting at one single point, making a horn-like formation. So these are the most important erosional landforms formed by the glaciers. So here you can see some images from the Swiss Alps of a U-shaped valley. So here's also a profile. These are made by the glacier, glacier movement. And here, this one, the small V-shaped profile, it's mostly formed by the flowing rivers. And here's the image of the famous Matterhorn in Swiss Alps. It is also very famous among rock climbers and the climbing community or hikers. People from all over the world visit this place. And as I mentioned before, this is a horn which is formed by three or more adjacent cirque glaciers eroding away the nearby areas and just leaving this one peak. And you can see these ridges next to it. These are arites, which I told about you before. And then we have some other glacial landforms, which are very famous. We call them fjords. They are basically glacier valleys, but submerged underwater. And these glacial carved valleys, they are basically along the coast. They are not inland. These are next to the coast, and they lie below sea level, and they get filled up with the seawater. Norway is famous for its beautiful fjords, and it's also called the land of fjords. And there can be two different types of fjords, like freshwater fjord and marine fjord. So here's a map of Norway, and you can see how the fjords look like on the west coast of Norway. So the whole entire west coast is it's full of fjords, like here, and they also call it like a fjord national park here in this region. So they are like very beautiful landscapes formed by glacial erosional processes. Here's a picture of one of the Norwegian fjords, and this is a very famous tourist spot called Trolltunga or Trollstang. You must have seen this picture at some point, I'm sure. Uh, Moving on, now we have some depositional glacial landforms. Um, so these are the landforms and features formed by glacier deposition. And here's a diagram of how it's happening. And as I showed it to you in the videos before, when the glacier moved down the slope, it brings down a lot of loose sediments and rocks along with it. And when it reaches the terminus or end of the glacier, where the melting is happening, these mixture of sediments, they get deposited here, and that's the initial process of formation of glacier landforms due to deposition. There are many different types of glacier depositional landforms, but we will look into a few of them and what they are. So the most important ones are called moraines. Then we have drumlins, we have eskers, we have kettles and glacial lakes. And here's a diagram of depositional landforms. So yeah, as you can see, this is the terminus or end of the glacier. Maybe it used to extend up to here, but since it's retreating, it has left behind the sediments here in different shapes and features, and it has moved back. So these are all formed by the deposition. So moraines are basically the sediments which are deposited parallel to the glacier laterally on the sides of it, and usually sometimes in the middle. Uh, I will show another picture. So these are the moraines, these lines that you can see parallel to the glaciers and next to them. Um, yeah. And then we have drumlins, which are small, elongated, 8 to 60 meters long depositions. They are very narrow and also in the direction of glacier um, advance and retreat. So the more sloping edge, it shows the position of glacier advance or which way it was moving. And then we have eskers. They are even more longer ridges, and they are formed by the deposition which has happened inside the glacier. Inside the glacier, there are rivers and melted water, small streams of melted water flowing, and they also have sediments in them. And these eskers, they get deposited by the internal melting of the glaciers, and they form like really long ridges. They can be kilometers long. Then we have kettles. They are basically icebergs stuck into the ground, and when they melt, they make these small kettle lakes. And then we have Glacier Lake. These are the big lake formed lakes formed due to glacier melting, and the sediments that are brought down by the glaciers, they form sort of a natural damming at one end, and the other end is dammed by a glacier. And then these small lakes they form because of melting. So these are some of the major depositional glacier landforms. And coming to an end of this lecture, we will talk a little bit about the fate and state of the glaciers in the current world. So as we hear a lot that the glaciers are melting and the climate is changing, so this is what it can look like in some glacier fronts or terminuses. This is called calving or carving. It happens where the glacier's toe or terminus meets the seawater. So many of the world's biggest glaciers in the world, they are melting or retreating rapidly, both in mountain and polar regions. They are significantly contributing to the sea level rise, as per lots of different studies. and they have impact on polar and marine biodiversity, of course. Lots of um, faunas in the polar and Arctic regions, they are suffering a lot with these rapid melting of glaciers. For example, polar bears, seals, Arctic foxes, and in southern polar regions, Antarctica regions, penguins, for example. Um, so it's a huge impact on the polar biodiversity. Also, glaciers are melting of glaciers is also causing hazards and natural disasters in mountainous regions like flash floods and affecting societies with the lack of water, which depend on glacier meltwater for their livelihood. So there are many different things or scenarios which are being impacted by the rapid glacier melt and the changing climate. So here are some take-home messages from this lecture. So the basic thing to remember is glaciers form where snow lasts all year round and turns to ice. Mountain glaciers, of course, form at high elevations and flow downslopes. Continental glaciers form in high latitude regions close to the poles, and then they spread over continents. In today's world, it is very important to continuously monitor and study the glaciers and glacier processes, as they have direct impact on human societies, biodiversity, and the climate of our planet. And lastly, glacier environments are very beautiful and pristine, and if you ever get a chance to witness or visit one, you should go for it, because in European Alps, there's a lot of beautiful places that you can just hike up to, not even that difficult hikes, and you can just enjoy the views of glaciers while they still last. I'm sure they will last for quite some time, but we can't say that with certainty. These are some references that I used and further reading material if you're interested to learn more about glaciers and the glacier processes. This one is a very basic book, and it's a beginner friendly in a way. This one is a bit more advanced, and that's it from my side. Hope you enjoyed the lecture, and thank you so much for your attention.